Okay, so we've been studying atoms, and if you've been paying attention, then you have a fair amount of knowledge about them. And we're getting down toward the end here, and I feel like I would really like for you to understand sort of some of the connections between atoms, electromagnetic force, chemical reactions, and your life, and the energy in your life. And so when we talk about life, we're talking about especially one kind of atom, and that is carbon. And we've talked a little bit about carbon when we were talking about the periodic table. And the three kinds of atoms that are going to be in the molecules that we're going to look at today, I think we've got some good demonstrations, is the three kinds are hydrogen, oxygen, and carbon. They're going to be the stars of the show today, and they are the stars of the show in your life, okay? Carbon, which is the jackknife atom, because it can, I probably don't have to shout into the camera, sorry. It can either lose force or gain force. So carbon can react with anything, as can hydrogen, because it can lose one or gain one. So these are incredibly flexible kinds of atoms. And so we're going to think of carbon as a jackknife because it can do so many different things. Hydrogen as a wild card because it can, it can really react with anything. And then oxygen is all around us, and it gains too, and we know it to be a bully. So in the story today, those are going to be the three stars of the show. Hydrogen, oxygen, and especially carbon. Okay, so what we're going to do in all the reactions today is we're going to add a little bit of thermal energy, and that's going to cause the reaction to happen. I know for a fact that you've experienced this, okay? And I've got evidence here. I was looking around the room, feeling nostalgic, and here's an exemplar from Maya, okay? And this is all about thermal energy and let's see, drip, drip, dragon drool, and dragon piston. Okay, so these are all about thermal energy and the reaction. So you saw this stuff happen in 7th grade. Speaking of 7th grade, right at the beginning of 7th grade, one of my all-time favorite memories was having Cambria come in and put these up, and this is Annabelle's, and I'll never forget standing here and watching Annabelle, see her work on the wall, and it is absolutely wonderful work, and it's dragon bucket and dragon breath and dragon dust, all in this journal entry that she did, and I love that kaplooey. So anyhow, what I'm going to talk about right now is just, I'm going to show you evidence of how, even though I know you've seen it, just more evidence of how a little bit of thermal energy can cause a reaction that wouldn't happen otherwise. So what we've got here is we've got some aluminum. I've had this aluminum in this can container. They probably have made this for 20 years. This thing's, before you were born, this strip of magnesium was sitting in my classroom, and it still is. I haven't used it yet. I'm going to use it today. What I'm going to do with it is I'm going to react it with oxygen, because I know that magnesium, let me just look here and make sure that you can see this. I know that magnesium, right, has 2 outer electrons, and to become stable it has to lose 2. And all around it in this room is oxygen. Oxygen atoms have 6 outer electrons, and they will gain 2, and oxygen is a bully, right? So what we're going to see is this react with oxygen. Okay, so why hasn't this happened, in the 20 years, 25 years, whatever, that it's been laying around my room? And the answer is, it has, but just on the outside. Okay, so there's stable magnesium oxide covering it and separating the oxygen from the magnesium. What I'm going to do is I'm going to add some thermal energy, right? You can also do that. And what that's going to do is it's going to cause the atoms and molecules to move faster, have more collisions, more intense collisions, and that's going to allow this chemical reaction to happen. Okay, so here we go. We've got magnesium and oxygen, and here's a little bit of energy just to get things going. Okay, right? Oops.